So what we're looking at in this video is a maximum volume question. There are quite a few details to this question. So if at any point in time you need to take the time to have a look back over what we've done, feel free to pause the video and take a moment to ensure that you understand where we're at. Now the question that we're looking at today, an open box with a rectangular base is to be constructed from a rectangular piece of cardboard 16 centimeters wide and 20 centimeters long by cutting a square from each corner and then bending up the sides. Find the size of the corner square that will produce a box having the largest possible volume. So what we need to look at is, what is this box going to look like? We don't necessarily need the dimensions, but we do need to understand that it may look something like this. It's an open box with the sides bent up. So one of the first things that you need to do when you're looking at this type of question that I encourage you to do, draw a sketch of the net. What is it that we're looking at? So this will give you an outline. So we've got the squares in the corner, which are an unknown length, x by x, where each of the sides where the dotted lines are will fold up to form a box. So if we have a look at the dimensions here, we have a length of 21 centimeters and a width of 16. So what are the lengths of the sides that we need to fold up? So if we have a look at the other sides, where they fold up, we have a length of 21 minus 2x, because we're subtracting two lots of x, one x from each end, and we have a width of 16 minus 2x, because again we're subtracting 1x from each end. Now what we need to do, because we're finding the volume, we need to establish what the volume of this box would be. So if we're doing length times width times height, we have our height, which is our x, multiplied by 16 minus 2x multiplied by 21 minus 2x. Now to come up with an equation, I'm going to expand the brackets here, which will give me x outside of 336 minus 74x plus 4x squared. And then if we multiply everything inside those brackets by x, we get 336x minus 74x squared plus 4x to the power of 3. So we have our equation here for the volume. First, let's have a look at some restrictions that we have. Now we know that the width of the box is 16 centimeters. So our x is going to be greater than 0 because it needs to have a length. It's also going to have 2x is less than 16. We can't have those two sides be going past the halfway point. So that will mean that x must be less than 8. That tells us that we want the greatest value. That tells us that we want the greatest value of v of x to be over 0 but less than 8. So let's differentiate v of x. So that will give us 336 minus 148x, because 2 times minus 74 is minus 148, x plus 12x squared, because 3 times 4 is 12, and then we subtract 1 from the power. Now I want to factorize this as far as possible. So each one of these can be divided by 4, which will give us 4 outside of 3x squared minus 37x plus 84. Now all I've done there is I've just changed the order around from highest power to lowest power. Within that, we can then factorize what's in the brackets to give us 3x minus 28 and x minus 3. So we have the differential of v of x is equal to 4 outside of 3x minus 28 and times by x minus 3. we need to allow that to equal to 0 to get a stationary point. So what we will do is, in order to find which ones will equal to 0, each set of brackets we allow to equal to 0, which will give us x is equal to 3 or x is equal to 28 over 3, which is equal to 9 1/3. So each of these could produce our maximum value. But let's have a look at the restrictions. The restrictions state that x has to be greater than 0 but less than 8. So that leaves us with x equals 3 as our solution. What we want to do is we need to first check that this is actually a maximum. So if we consider when x is less than 3, the differential of v with respect to x is greater than 0. So we can do that by substituting in, but that will give us a positive gradient. So those values less than 3 will have a positive gradient. It goes up. When x is greater than 3, then the differential of v with respect to x will give a negative value or a negative gradient. If we have a look at that image that we've produced, those values before 3, the gradient goes up toward the 3, those values after 3, the gradient goes down. So we get their highest point at 3. So therefore we know that there is a maximum at x is equal to 3. What we're going to do now is we're going to find the volume. So v of 3, and we're putting it back into the original volume, not the differentiated value. That will give us a result of 450. The maximum volume of 450 cubic centimetres is for a corner square 3 centimetres long. I hope you found this helpful.